Okay, so in this video I am explaining formulas from Module 2. Module 2 name is moment of inertia of plane area. Okay, so first formula is perpendicular axis theorem. When any body, here is some random body we have taken, and if we have to find out moment of inertia with this axis and this axis. This body lies within xy plane. Okay, this will be xy plane. Okay, so if the moment of inertia we have to calculate for the OZ, means which is perpendicular to that plane. Okay, so moment of inertia with respect to OZ is equal to OX IOX plus IOZ. Okay, means moment of inertia with respect to OX plus moment of inertia with respect to OY. Okay, so OZ we call it as polar axis, and IOZ means that moment of inertia which is perpendicular to that plane. It's called a polar moment of inertia. Okay, next is parallel axis theorem. Okay, it will mostly use theorem. Okay, so when we have to calculate the moment of inertia around that axis which is parallel to the axis which is parallel to the centroidal axis. Okay, and distance between this is centroid with that axis is y bar. Okay, so it's a centroidal axis because it's passing through a centroid. Okay, so what will be its formula is IAB, means moment of inertia with respect to AB is equal to IXX plus AY bar square. It means A is area. Okay, IXX will be centroidal axis formula. Okay, in that both the formulas. Okay, in this formula we have used the centroidal axis moment of inertia. Means moment of inertia with respect to that axis which is passing through the center of gravity. Okay, that moment of inertia we have a standard shape and standard formulas. Okay, so if we calculate IXX, we can simply find out I of AB, means moment of inertia with respect to any line, where means if we draw a line here. Okay, A B, we can also calculate the moment of inertia with respect to that line. Okay, how can we calculate? So we will draw a line here which is parallel to that AB line. Okay, it will be our new axis YY. Okay, so we measure the distance between this. Okay, it will be x bar. Okay, I am taking the example. Okay, so we know the formula of IYY because it is passing through the centroid, because we have a standard shapes and standard formula for area moment of inertia. Okay, there are several moment of inertia. We will be next having the syllabus in Tom, where you can get a mass moment of inertia, but here is you have to calculate only area moment of inertia. So if we got the ixx, ixx or iyy, we can easily be find out the any lines moment of inertia. If we find out any lines moment of inertia, then here is ox. You see, it's not a centroidal line. It's not also a centroidal line. But when we found out the moment of inertia with respect to that axis, we can easily find out the moment of inertia with respect to the perpendicular axis. Okay, means polar axis. Okay. Next, standard formula here is there are the standard formulas. Ixx means Ixx is bh cube by 12 means here you know. Okay. Here no need to explain this formula. Ixx when we are asking for Ixx, you can directly use that formula. Iyy will be b cube h by 12. Then I with base means I with this line. Okay, I with this line. Okay, if this line is base, then what will be our parallel axis theorem? I base is equal to Ixx plus a into y bar square, right? A into y bar square. Okay. Here is we know Ixx. What is Ixx? bh cube 12. Okay. Then plus what is area of its rectangle? B into h. Okay. B h. Next, what is y bar? B this base to that centroidal axis distance, perpendicular distance between them is h by 2. H by 2. But we have to take a square of that. So h by 4. Okay. So bh cube plus bh cube by 12. Means here we need to 3. Here we also need to take a 3. So 3 plus 1 is 4bh cube by 12. Okay. So 3 is a 12. So here is I base. Right? To understand how we calculate this with I base. Okay. With a simple parallel axis formula. Okay, I have provided you that this PDF, so you can easily grab this and please note down all of the formula in your book. Okay, so you can easily access it for the next problems when we solve. Okay, so for square you can easily take that means I base. Here we can take this base. Okay, here is a bh cube by 36 for ixx only. Here is no iyy because when you have to take this axis, so you have to take this b and here axis, right? Here axis, then this will be to take b and then it will be h by 3, then here will be 2h by 3. Okay, so you can simply convert it for a triangle. Then for a circle, it is pi r raised to 4 by 4. You have to by heart all the formulas, that standard formulas. Okay, I have provided you all the PDF to only by heart all the formulas. Okay, no any single formula you have to you have to skip. Okay, so I of AOS means the axis of symmetry is this axis. Okay, and the semicircle will be take that pi r raised to 4 by 8. Okay, simply pi by 8. Okay, then XX with that IXX, then quarter circle pi r plus 2 4 by 16. Okay, next in that module